Alright, welcome everyone. This is topic 8, page 31 of the workbook, and question 3. Alright, we'll begin. A plane is seen by a person on the ground to travel in a direction of south 30 degrees west or 30 degrees west of south, if you'd like. If its speed relative to the ground, which is ground velocity, is 300 kilometers per hour, and the wind velocity is 150 kilometers per hour south, what is the plane's velocity relative to the air? Alright, so first of all, person on ground viewing the plane, we know that's going to be our VPG, our velocity of our plane relative to the ground. Let's keep going. Velocity of the wind, alright, so we know that's the velocity of the air relative to the ground. And finally, velocity relative to the air for that plane, that's going to be our VPA. Alright. It looks like here, this is what we're trying to find. Alright, so for that velocity of the plane relative to the ground, that is going to be our value of 300 kilometers per hour. And our direction here is going to be south 30 degrees west. Okay? For that velocity of our air relative to the ground, that's going to be 150 kilometers per hour just south. Okay. Let's create a reference frame real quick. So we're going to have north, east, south, and west. Since only south and west have come up, I'm going to make north and east negative and south and west positive here, okay? Perfect. Let's check our values one more time. That looks like everything should stay positive. So before we get into our calculations, I'm going to draw a diagram real quick. You can do the same. Here's our plane right here, and it's going to be heading this way. If this is our vertical line, since it's 30 degrees west of south, that's going to be this angle here. If this is south and this is west, that's going to be 30 degrees here. This is going to be 300 kilometers an hour, which is our VPG. Perfect. Then we've got that 150 speed relative to the ground of our air. So that's going to be right here. That's our VAG. Oops. And that's going to be 150 kilometers an hour. So what we're looking for is this here. And how we're going to find this is going to be by breaking down everything into their x and y components. Now, as you can probably see here, the 150 is already completely south, and therefore it only has a y value, which is great for us, which means we only have to do this right here and break it down into those components. So I'm going to make a little chart here. VPGX equals VPGY equals VAGX equals and VAGY equals. So right away, we already know there's no x value for that AG. So we'll write 0 here, and then we'll write 150 kilometers per hour here. So we're just looking for that x and y VPG. All right, we'll go back over to the left here and start solving for this. So this is going to be our shape here. We'll just highlight this, 30 degrees and 300 kilometers per hour. I'll draw a dotted line here. So let's start off with that x component first. Let's find the x. So we're going to be using sine, because sine is equal to opposite over hypotenuse. And that's going to give us, once we rearrange it, our opposite value, which is our x. So in other words, sine equals x over our hypotenuse. All right, Perfect. So let's do some rearranging here. We're going to have hypotenuse times sine equals opposite, or x. So 300.0 kilometers per hour times sine of 30 degrees equals, let me put that into my calculator. That's going to give us exactly 150 kilometers an hour. Perfect. And I'll just rewrite this here so we know. Let's go back to that chart, fill that out there. That's the VPGX. That's going to be 150 kilometers per hour. We'll do the exact same thing here, but for our adjacent angle. So we're going to be using cos. So cos equals adjacent over hypotenuse, or cos equals y over hypotenuse. All right, so same thing here. I'm going to skip the rearranging steps because I just showed you how to do it and it's the exact same. Times cos of 30 degrees. Let me punch that into my calculator. All right, that's going to give us a value of 259.8076, rounded to 259.8 kilometers per hour. Perfect. I'll just really highlight here that this is our y, and this was our x. So we know. All right, let's go back over here. That was 259.8 kilometers per hour, I believe. All right. Now let's write down that equation that we discussed earlier. Our equation was, oops, let me go here. The velocity of the plane relative to the air is equal to velocity of the plane relative to the ground minus the velocity of the air relative to the ground. And this is just the basic equation rearranged so that we have isolated the velocity of the plane relative to the air. We can also rewrite this as VPAX equals VPGX minus VAGX. Same thing for y. Let's begin and find that x value. So we're going to do VPAX equals 150.0 kilometers per hour minus 0, because that x here was 0 earlier, equals 150.0 kilometers an hour. Perfect. We'll do the same thing for y. So VPAY is equal to 259.8 kilometers an hour minus 150.0 kilometers an hour. That's going to give us a value of 109.8 kilometers an hour. Okay, perfect. Now what I'm going to do is quickly draw this. So what we have here is our y value. X value is going to be 150.0 kilometers an hour, and our y value is going to be 109.8 kilometers per hour. So what we're looking for is sort of this, and this angle here. Okay, so to find our VAG velocity, AP, velocity of the air relative to the plane, we are going to use the Pythagorean theorem since we're finding the hypotenuse. So that's going to be 109.8 kilometers per hour. You could also find the angle first and then use SOHCAHTOA to find the hypotenuse, but I'm just going to do it this way first because it's easier. Plus 150 kilometers per hour squared. That's going to be, let me put that in my calculator, 185.9 kilometers per hour, or 186 kilometers per hour. So that's the first part of our answer. Now we just need to find the angle. So that theta is going to be equal to inverse tan 109.8 is going to be equal to our x over our y. So that's going to be 150.0 kilometers per hour. I'll zoom in so you can see a little better. Over 109.8 kilometers per hour. This is going to give us a value of roughly, let's see, pull up your calculator. Okay, 53.798, or 53.8 degrees. Since this is greater than 45, I'm going to inverse it through 90 to get a value of 36.2 degrees. And the direction is going to be, what is it? Yes, west, because what we've done here is this was our 50, this angle here was our 50-degree angle. This angle here is going to be the angle we just found since we inversed it. It's going to be west 30, or let me rewrite that, south of west. We can see that there. All right. So, therefore, the velocity of the plane relative to the air is 186 kilometers per hour, and I'll write here, west 36 degrees, 36.2 degrees south. That is the final answer. So here's everything we just did. All right, thank you guys.